Hello, you guys. Let's talk about scientific notation. Now, just like the word is telling you, scientific means it shows up in science a lot, and notation just means it's another way to write a number. But before I explain how to do it, you have to understand what we're trying to do. We're trying to take any number that they give us and write it as a product of two numbers, okay? So look over in the margin, write scientific notation, and then I want you to put a red box. Now this box is the first number in scientific notation, just kind of like your first name, okay? This first number must be between 1 and 10. But I tell people, think about money. It has to be between $1 and $9.99. It cannot be less than $1 and it cannot be more than $10, okay? So that's where it is, in between there. Okay, now this second number right here, we always put the first number and then we put a time symbol and then we put the number 10 and then we give 10 a power, okay, an exponent. And this power can be a positive or negative integer. It's a whole complete number and it's either positive or negative. All right, so let's do one of these together. Take a look here, 289,000. Okay, so the first thing I always tell people to do is write 289000. Then grab your red pen and put the decimal point where it's supposed to be. It's supposed to be at the end of the number. Just put it there so you can see it. And then I tell people, grab your blue, okay, and you put a star anywhere in the number to create a number between $1 and $9.99. So I put the star right here to make 2.89 because $2.89 would be between $1 and $9.99. And then you count, okay? And I want you to notice something. There's a star, there's a decimal point. You want to shoot an arrow towards the decimal point, like you're going to pop that big red balloon. And notice how it's going to the right, okay? And now we count every digit between the star and the decimal point. So I see 1, 2, 3, 4, 5 numbers between the star and the decimal point. And so I take those first three numbers right here, 2.89, that's the number between $1 and $9.99, and then I put a times, and then I put the number 10, and then remember how I counted 1, 2, 3, 4, 5? I put a positive 5 because my arrow was shooting to the right, like the positive numbers on a number line. Okay, take a look here at this next example, okay? Example 1, it says lightning. A flash of lightning consists of 3 or 4 strokes. The time between each stroke is about 0.00005 seconds. Write the number in scientific notation. So the first thing I want everybody to do is write the decimal that they gave us, 0.00005. And then use your red to find the decimal point. And this time we can see it, so I'm going to circle it in red. And then I'm going to put a star with my blue pen to create that number between 1 and 10, that first number. So the star has to go after the 5 to make $5. That $5 is between $1 and $9.99. And then I shoot an arrow from the star to the decimal point, just like I was going to shoot an arrow to try to pop that balloon. And notice this time how it's going to the left. And then I count every digit between the star and the decimal point. So I see 1, 2, 3, 4, 5. So I grab where the star is, that number that's by the star, the 5, and you can put 5.00 if you want. Make it look like money. So $5 times 10. And then I use, since it was going to the left, my arrow was pointed to the left, I put a negative, and then I counted 1, 2, 3, 4, 5. So it's 5 times 10 to the negative 5th power. Okay, so let's try another one. It's example 2, space. The maximum distance from Earth to Jupiter is 968,100,000 miles, or kilometers, sorry. What is the distance written in scientific notation? So the first thing I tell people to do is write the number that they give you on your paper. So write 968,100,000. And then with your red, put the decimal point in so that you can see it, okay, a big red decimal point. with your blue, grab your blue, and I want you to put the star in the number to create a number between $1 and $9.99. So notice how I put the star between the 9 and the 6. Okay, and then I shoot the arrow from the star to the decimal point, like I was going to pop that big red balloon right there. And I notice that it's going to the right, which is going to make my exponent positive. And now I count every digit between the star and the decimal point, everything, including the zeros. Count it all. So 1, 2, 3, 4, 5, 6, 7, 8. So now I can write my number in scientific notation. I grab those first three numbers, 9.68. Remember, that's between, it's 9.681. They gave us one there. And that's between $1 and $9.99, okay? Then I put times 10, and then I counted 8. And since it was, the arrow was going to the right, it's a positive 8. So in this case, it would match choice C. Okay, now in example 3, they're going to change it on us. They want us to write the numbers in standard form. Now, I haven't mentioned standard form before, but standard form is just the normal way you would normally see the numbers written, with all the commas and all the zeros, okay? That's what standard means. So this is even easier, I promise. So watch, if I want to write 3.1 times 10 to the 7th power in standard form, all I do is write the number they gave me, 3.1 times 10 to the 7th, and I always grab my red and I circle the exponent because the exponent is the key. That tells us exactly what to do with the decimal. Notice how this exponent is a positive 7. That means they want me to grab the decimal point and move it 7 places to the right, in the positive direction, okay? So I grab my first, the first number, the number that's between $1 and $9.99, and I put it on my paper, 3.1, and then with my red, I grab the decimal point and I move it 1, 2, 3, 4, 5, 6, 7 places to the right, and I put the decimal point there. Remember, I'm grabbing the decimal point and dragging it over. And then in those little spaces that I've created, I put zeros. So you'll notice I put those zeros, and now I write the number in standard form. So that would be 310000000, decimal point. So notice it's at the end. Now we're supposed to put the commas in correctly. So from the decimal point, count backwards. 1, 2, 3, put a comma. 1, 2, 3, put a comma. And now you could read that number to me. That would be 31 million. Okay, take a look at B. If they gave me 9.08 times 10 to the negative 4th power, and they want me to write it in standard form, I write the number that they gave me, 9.08 times 10 to the negative 4th power. With my red, I circle the exponent because that's telling me what to do with the decimal. Negative means move it to the left for 4 places, okay? So I write that number that they gave me, the 9.08. Whoops, and I just see that I made a mistake here. Let me grab my pen and fix this real quick. So I put 9.08 there, and this should be a 0 in here. Okay, so now I'm going to grab my pointer, and I grab the decimal point where it started, and I move it backwards 1, 2, 3, 4 places. So my answer, look up here, I wrote point, and then I have 000908. And I can box my answer. This is the number in standard form. Okay, what I want you guys to start to do before you play the movie for guided practice, I want you to pause and try these on your own, okay, and see if you do them right. But you can check them with me when I'm explaining it, okay, but you should try them first. So take a look at number 1, 9,000. They want me to write it in scientific notation. That means a number between $1 and $9.99 times a power of 10. So I write 9000 on my paper. I use my red and I put that decimal point. I grab my blue and I put the star somewhere in the number to create a number between $1 and $9.99. So I put the star right there between the 9 and the 0. and then I shoot an arrow toward that balloon that I'm going to pop, and I notice it's going to the right, which is going to make my power positive. And then I just count every digit between the star and the decimal point. I see 1, 2, 3, so now I can write the number 9.0. Remember, it grabbed the number with the star, so like $9, times 10 to the positive 3, because there were 1, 2, 3 numbers between the star and the decimal point. Okay, take a look at number 2, 253,000. So first thing I do is write 253000, and I put my decimal point in with my red pen. And now I grab my blue and I put a star to make that number between $1 and $9.99. So I put the star between the 2 and the 5. Remember, I shoot the arrow toward the red balloon, so that is going to the right. So I know my exponent's going to be positive. And then I count how many digits there are between the star and the decimal point. 1, 2, 3, 4, 5. So then I write 2.53 times 10 to the 5th power. Okay, take a look at number 3. The first thing I do is write the number they gave me, 0.000012. And so with my red, I circle that decimal point to make that red balloon, okay? And then with my blue, I put a star somewhere in the number to create a number between $1 and $9.99. So I'm going to put the star between the 1 and the 2, and then I count. So watch, when I shoot the arrow from the star to pop that balloon, notice how it's going to the left this time. That means my power is going to be negative. And then I count 1, 2, 3, 4, 5, 6. So it's 1.2, and you can put the 0 if that helps you, like $1.20, times 10 to the negative 6th power. And remember, it was negative because the arrow is shooting to the left to pop the balloon. Whenever it shoots to the right to pop the balloon, it would be positive. Okay, now take a look at number 4. They want us to write the number in standard form. That means just use the power and move the decimal. So I write 8.2 on my paper, and I circle the power. See how it's positive 2? That means grab the decimal point and move it 2 places to the right and put the decimal over here. So that gives you 820. And that's the number in standard form. Take a look at number 5. 5.51 times 10 to the 10th power. So I put 5.51 on my paper. With my red, I grab the decimal and move it 10 places to the right. And then I put the decimal all the way at the end. So then I write 551, and then I had to add 8 more zeros. Because remember, this counted as 1 movement, 2 movements, and then I had to go 8 more to get up to 10. Okay, so then once I know the decimals at the end, I count backwards. 1, 2, 3, put a comma. 1, 2, 3, put a comma. 1, 2, 3, put a comma. So that you could read this to me. This would be 55,100,000,000. Okay, take a look at number 6. 6.49 times 10 to the negative 9th power. So I put the 6.49 all the way over here to the right, and then with my red I circled the exponent, I circle my decimal, and I moved it 9 places backwards, all the way back there. So then I put a decimal, I added 8 zeros, and then the 649. Okay, so let's kind of summarize what we did. Put the word scientific notation here, and it's okay if you abbreviate in the middle. So if I were asking you to define it, remember, it's a number between $1 and $9.99 times 10 to the power of. You're going to have to figure out the power. It's an integer. It could be positive or negative. And then I wrote it out here. A number between 1 and 10 times an integer power of 10. That's what scientific notation means. These are some examples, like 6.21 times 10 to the 3rd power. That would be an example. 3.9 times 10 to the negative 8th power. Those would be great examples of scientific notation. Now, non-examples would be this. 15.7 times 10 to the 3rd power. At first it looks good, but remember, this number, this front number, cannot be bigger than 9.99, so that wouldn't work. This is also a bad example because look at 0.83 times 10 to the fourth power. You cannot have a number here in front that's smaller than $1, okay?